everybody. I'm Lin Clark, and I'm here to talk about making small modules actually work for the front end with Webpack and NPM. But before I start, I feel like I really need to clarify what I'm talking about when I say small modules and modularity in this talk. Because unfortunately, these words have become associated with something called module shaming. You know, when you say them, there's a fear instilled in your listener that you're going to wag your finger at them and tell them, you don't know what you're doing, you don't understand modularity, you're not doing it right. And that fear is not unfounded. I actually stumbled across an example of it just while doing the research for this talk, and I want to talk about that example. But first I want to explain why I'm giving this talk. I was at jQuery SF a few months ago. I gave a talk about Browserify, which is a tool very similar to Webpack. And Matt saw this talk. You know, I covered a lot of the concepts behind Browserify and why you might want to use it. And he said, I think a lot of these concepts are why React is taking off too. I'd love to see this talk at React Rally, but a lot of us use Webpack. Would you be okay with modifying it to use Webpack? And I'd been looking for a chance to dig into Webpack, so I said, sure, I jumped at the chance. And so I sent him my title, I sent him my description, talking about small modules, and then I started figuring out what I actually wanted to say. I started doing my research, and it was in doing my research that I stumbled on something that really bothered me. It was a comment that I'd seen before, and you know, it had struck me a little odd when I first saw it, but it really hit me this time. And that comment was, after reading all of the comments here, I'm pretty convinced that none of the Webpack people know what modular means. And my reaction was this. Now, I'm not going to name the person who said this. I know him, I like him, and I think that he might not have realized, he might not have intended it to come across the way that it did. But I think it's a really concise example of this sentiment that I've seen a number of times before, and I think it's worth addressing this sentiment in general. Now, somebody else in the thread clarified what modular means, saying, the problem is that they're all delivered as a single package. And this is an issue that you do see small module evangelists talk about a lot. The idea that there must be a one-to-one correspondence between module and package in order for something to be modular. You know, it's like, if things are not labeled for individual sale, they aren't modular. Now, I've been studying and, you know, talking about modularity for a number of years, both when I worked at NPM and before that when I was working at a research institute where we focused on things like distributed extensibility and also just on open source projects, large open source projects across a number of different languages. And I have to say, you know, I've been exposed to modularity across a number of different contexts. And I can tell you that this is not a canonical definition of modularity. The idea that there has to be a one-to-one correspondence between the module and how they're packaged, that is not a canonical definition. Oops. Pardon me. It's a definition that has evolved in a small and close-knit community of practice. Now, that's not a problem. What is a problem, though, is when people from that community of practice go out to other communities and treat their evolved definition as if it's canonical, as if it's universal. And they treat, especially when they treat the evolved definition as a cudgel to hit people over the head with when they disagree. If you look at the early writings about modularity from computer scientists, I'm talking about in the early 1960s, when we were moving from a pre-modular era of computing to the modular era of computing. You'll see that what they focused on with modularity was really general problem solving. It was taking these large, complex problems and breaking them up into smaller, more manageable problems. Things that you could fit in your head all at once. You know, getting back to Jessica's point this morning, if you want to be able to scale your problem solving, you have to reduce the things that you need to focus on all at once. And so that was what modularity was developed to address, really. The idea that this packaging up, that this reusability is a requisite for something to be considered modular isn't something that I've seen too often. even if you look at the Unix rules, and Unix is the tradition that a lot of these small module evangelists look to, even if you look at the Unix rules, the rule of modularity doesn't talk about reusability, it talks about readability. It talks about being able to, having modules that you can fit all in your head at once so you can debug them more easily. So often in these discussions, reusability is framed as a benefit. Once you've modularized something, once you've actually, figured out how to break it into this small unit, then you can extract that, package it up, and make it so that it can be reused in other contexts. But that's not usually the criteria that is used to assess something's modularity. The criteria that are often used to assess modularity, or at least that I've seen, are cohesion and coupling. And so I'll explain what those are. Cohesion is the degree to which elements of a module belong together, and the degree to which things that belong together are part of the same module. So an example of this would be if you have a getter and a setter for something. They should be in the same module. Now that's a really, really simple example, but I think it gets the general point across. So the other thing is coupling. Coupling is the degree of interdependence between modules. Now, if modules are tightly coupled, they poke at each other's internals. They start reaching in to change each other's state. You want loose coupling so that you don't have to think about how another module is changing the state of the module that you're thinking about. It's like these tentacles that Jessica was talking about this morning. You don't want to have to think about what tentacles are coming in and changing what's going on with this module. And you can reduce coupling by creating interfaces. Instead of having a global object that these things are working with and poking around at, creating interfaces, so making it so that the caller is explicitly passing things in to the callee, and the callee is passing a return value back. So you build these interfaces to reduce that coupling. So when I talk about modularity, these are the things I'm going to be talking about: cohesion and coupling, high cohesion and loose coupling. Now, I will also talk about how when you do these things, it makes it possible for you to then extract the functionality out and package it up. And I'll explain how you can do that. But that's not a requirement in order for it to be modular. So there's going to be no module shaming in this talk. With that out of the way, let's talk about the problem that both of these tools address. The problem that both Browserify and Webpack solve is how to bundle up modules so that they can be loaded in a browser. So how you take this dependency tree and put it into a JavaScript file that you can include in your web app. Now that's still pretty abstract. I want to make sure that we're all on the same page about this problem, so I'm going to give a concrete example. I want you to think back to when jQuery was the library du jour, and how all of your clients wanted you to do these tooltips. Remember these, how that made your site look super fancy? Now here's the code for that tooltip. It's using jQuery to get a list of elements, and then calling the tipso function. I'm using the tipso jQuery plugin. Calling the tipso function to add that tooltip. Now I'm going to let you in on a little secret. This actually won't work. And does anybody have any idea why this won't work? You can shout it out if you do.
It's not loaded, not ready yet.
Other ideas? Even more fundamental one. We don't have jQuery included. We don't have a script tag for jQuery or for tipso. So what these script tags do is they give your app a way, pardon me, they give your app a way to say, hey, browser, before you work on my code, load jQuery and load tipso. They give your app a way to express these dependencies explicitly. So what they're doing is giving you a way to express dependencies. What would happen if we flip these around? It should be fine, right? Because we're just expressing dependencies. If we switched tipso, put tipso at the top and jQuery underneath, That should be fine, right? Does anybody think that this will break everything? Okay. And the reason it will break everything is that TIPSO has its own dependency on jQuery, but it's not expressed. There's no way for you to express this with script tags. You can't make this implicit dependency explicit. And you really don't even want to do that in your application. You know, we were talking about cohesion. That's information that TIPSO should be in control of. TIPSO should be in control of specifying its own dependencies. That's what these tools make it possible for you to do. They make it possible for libraries like TIPSO to declare their own dependencies, and to do that using module syntaxes like COHESION, or as Jem was talking about earlier, there's, of course, ES6 modules. So that is the basic problem that these tools help you solve. They help you bundle up your dependencies for the browser. So the basics of bundling. How do you get Webpack to give you this basic bundling functionality? Well, with both Browserify and Webpack, you have the concept of an entry point. This is the root of your dependency tree. And you also have your output file. So this is the JavaScript that you're going to end up putting in your application. For Webpack, you put this in a Webpack config. So you have your entry, and then you have the output. The output should have a path and a file name. The path will be used because Webpack also lets you do images. So the path will be used for assets other than just this bundle. You want to make sure that you don't just include the path and the file name. What about the case where your input doesn't match your desired output? For example, when you have JSX somewhere in your application. In this case, you can use loaders. And a loader is like a transform in Browserify. It inserts itself, it loads the code that's coming in, and ensures that your system, that your application can parse it. The way that you specify loaders in your application is the loaders array. For JSX, I would download something like the JSX loader. I happen to like the Babel loader, so I would use the Babel loader. And then you specify a test. This test lets your application know which of the files in your tree should have this loader applied. So this is a regex that would say any JS files or JSX files should have the Babel loader applied. And when I'm doing this, I also like to use the resolve extensions just to make sure that when I'm using my require, when I'm including my dependencies using require, I don't need to have the file extension on there. So that's just a nicety. It's not necessary. So I said that loaders and transforms, Browserify transforms were pretty similar, and I feel like I need to explain the differences because this is a point of controversy. This is a point where people who are Browserify supporters will point at Webpack and say, that's not so modular. And the reason for that is that loaders are specified at the application root. You have your Webpack config for your application, and those apply to your entire tree by default. But what if there's a package underneath that tree? Having those loaders specified at the application level and then apply to everything in the tree, that really doesn't seem modular. What Browserify does is it gives you transforms that can be applied at the application level, but also every single package, everywhere there's a package.json, you can have different transforms. And this does seem more modular. The package should be in charge of specifying what transforms can be applied to it. So when I came into my research here, I actually was on Team Browserify. I thought that was kind of an unmodular way to handle things. But then I learned a few of the other features of Webpack that help get around that problem. The first one I learned about is that you can include and exclude different paths from the loaders. So I could say that I don't want anything in node modules to have the loaders applied. Or I could say, include these specific paths. That's actually the better way to do it. That's the more recommended way to do it. But there's one more problem there, because we have the JSX file in this package, and we do need a loader applied to that. But we don't want to have to specify that at the application level. We want that to live with the package, that information as to what loader should be applied to it. So the way you can get around that is with libraries. And I found out that a lot of people, it's kind of this hidden functionality of Webpack that a lot of people don't know about. libraries make it possible for you to ensure that your loaders are applied. They kind of create an intermediary bundle that then your application can load. So it's all transpiled and everything is put into your single JavaScript file, but then your application can insert any of the other dependencies like React that it needs. And so I'll be showing libraries at the end of the talk, but for now, I'll just show you how you can exclude and include different things from your loaders. So if you want to have a particular set of paths included for a loader, you just specify right there in the loader spec. So we have the basic bundling set up. How can we increase cohesion and decrease coupling? How can we start making it more modular? I'm sorry, the network is a little slow right now. The presenter network seems to be a little slow. Okay, I think I should be okay. So how can we make this more modular? We can use loaders for CSS. So this allows you to require your CSS from your component. This means that you can deliver your CSS wherever that JavaScript for your component is being loaded. You can deliver your CSS at the same time without your consumer having to do anything. And the way you can do this is by using the CSS loader and the style loader. So the CSS loader, that actually will look at any CSS files that you're using with require, because normally you get an error when you try to require a CSS file. But with the CSS loader, it's actually able to parse CSS, and then it will pass it into the style loader. That exclamation point in the middle there, that is separating the two loaders. It will pass that parsed CSS over to the style loader. The style loader is going to insert it into that JavaScript bundle. So the nice thing about that is that you can ensure that your CSS is included right there in your JavaScript bundle. It doesn't require your consumer's application to know anything about what CSS it's supposed to load. So that helps with cohesion. How can we do some decoupling here? There's a new feature, or a relatively new feature of Webpack called local scope CSS. And the local scope CSS gives you a way in your CSS file to say that certain classes, certain rules, should be handled as locally scoped. You shouldn't have them applied to other components, basically. So you specify it in your CSS, local colon, and then parentheses around the class name. The exported CSS won't have that class name. It will actually have a base64 encoded token. And this token, it isn't used in other components. It's only used in this one component. The way that you get your React component to know what token to use, when you require your CSS, you assign it to a variable, and then in your render function, where you have your class name, you just use that. Use it as a property. And so what this does is if you have your component here and your component there, they both use the foo class, the rules for this one will only be applied here. The rules for that one will only be applied there. This helps you really decouple that. It gets rid of that global CSS problem. So you can load CSS. You can also load images. The URL loader will take an image, load it. If it's smaller than a certain size, it will create a data URL for it and just insert it right into your component. And that, again, helps with cohesion. So we've looked at how you can increase cohesion and reduce coupling. And this has really made it modular. This has made it possible for you then to package up your component so that it can be reused in other contexts. So here's your application, and that is the little bit of functionality that you want to package up. So we're going to move it to be a sibling, to be at the same level as our application, so that another application could start depending on it. Now this one starts to get a little bit more complicated. Bear with me. What you're going to do is you're going to take that part of your tree, move that component next to your application, so it's at the same level. Then you're going to cd into your components directory. You're going to run npm init to create a package. So you give it a package name. And then you run npm link from inside that package. What that does is it tells npm that there is a module named foo, whatever you called your module, that's here. It tells npm, make a link from the global npm space down to here, so that whenever anybody asks for foo, look over here. And then you cd back into your application and npm link and your module name. And so that will tell your application where it can find this module, even though it didn't download it from npm. When you do this, though, you're going to have an error, most likely. And this error is going to be because it's loading 2 copies of React. There's a copy of React in your components directory, in the node modules in your components directory. There's a copy of React over here in your application directory. And React expects to be a singleton, expects that there's only going to be 1 copy of it loaded. So the way that you get around this is go into your components directory and remove that copy of React. You can also do other things. You can shrink wrap it so that it doesn't get downloaded again, but shrink wrap has its own problems. So I would recommend just manually remove it, and if you need to, remove it again later. Then you run into another problem, and that is because now that you've removed this copy of React from your component, when Webpack in your application goes up, finds this dependency and starts running Webpack over here, looking for React over here, there's no React in the node modules directory. So to get around this issue, what you need to do is use, in your application directory, specify where resolve should fall back to. If it can't find its dependencies over here in the node modules directory, fall back to the applications node modules directory. And then I talked about libraries. This is how you make sure that your loaders are applied. This is the specification that you use for a library. You specify your library target, and your library target is what module syntax you want to use. I use UMD. And then you specify the externals. These are the things that should not be included in your library. So you don't want React included in your library. So let's review. How do you actually work with small modules in Webpack? Increase cohesion and reduce coupling by using loaders to include CSS and images. And then you can increase reusability by using npm link to develop your application and your component concurrently, and libraries to ensure that your loaders are applied. If you want to explore this further, I can recommend these resources. And the slides are available here. I don't recommend downloading them over conference Wi-Fi, but when you get home. If you have any questions, you can ping me. I'm Lin Clark on Twitter, and thank you very much.